Traffic accidents occurring on any given day in Coralville is Poisson with mean 5. Probability that any such accident involves an uninsured driver is 0.75. Independent of all other such accidents, calculate the probability that on any given day in Coralville there are no traffic accidents that involve an uninsured driver. So first thing to note is that the number of accidents is Poisson with mean 5. So let x be the number of accidents in a day. And that's Poisson with mean 5. So f of x is equal to 5 power x, e power negative 5 over x factorial. Remember, for Poisson distribution with mean m, the PMF is m power x, e power negative m over x factorial, where x is the number of successes, which in this case is accidents. So we want the probability that none of the accidents happen with uninsured driver, which is another way of saying, so this is what we want, calculate the probability that on a given day, none of the accidents involve an uninsured driver, which means all the accidents are with insured drivers, right? That's the same as saying that none of the accidents are with uninsured drivers. Now, the number of accidents could be anything. It could be 0, 1, 2, 3, 4, keep going forever. So all accident, we want all, no matter how many these accidents are, we want all of them with insured drivers. So as we said, number of accidents could be 0, 1, 2, 3, so on. So if you have k accidents, you want the probability that you have k accidents and all of the k drivers are insured. And k could be anything from 0, 1, 2, 3, so on. So 0 to infinity. You could have 0 accidents and 0 insured drivers, or 1 accident and 1 insured driver, or 2 accidents and 2 insured drivers, and so on. And see, we're talking about 0 or 1 or 2 or 3. So that's why when you break it up, it's a sum. It's a sum of 0 and 1 and 2 and 3 and so on. And then here we have and between these two, k accidents and all of the k drivers insured. So that's probability k accidents times probability all the k drivers insured. So okay, let's so probability k accidents is the f of k according to Poisson. So 5 power k over e to the negative 5 over k factorial. And probability all the k drivers insured is 0.75 power k. So let's just do one more step here. So we are given that the probability that the driver is uninsured is 0.25. So therefore, probability that the driver is insured will be 1 minus 0.25 equals 0.75. And probability k drivers insured would be 0.75 power k. Okay, so that's why when you break this up, so let's just copy this. The probability all accidents insured drivers. So here, when we substitute the values, k accidents, we already know that's this f of k according to Poisson, and all of the k drivers insured would be 0.75 power k. So now this looks an impossible summation at first sight, but we will play a little trick. First of all, we will multiply this, we'll combine this 5 power k and 0.75 power k. And so I leave the e to the negative 5 over k factorial, and I combine the 0.75 power k and 5 power k into 1. So I have 0.75 times 5 and whole power k. And now 0.75 times 5 is 3.75. So now if you look at this summation, this almost is a Poisson PMF. But remember, in a Poisson PMF, whatever you have to the power k, you have e power the same thing. So remember, it's e power the mean, negative mean power k over k factorial. But here, this 3.75 is not quite the same as this negative 5. We need to match these up. And the way to match this up will be to break up this e power negative 5 into e power negative 3.75 minus 1.25. So negative 3.75 minus 1.25 is negative 5. And we need this negative 3.75 because we have a 3.75 over here. So now we don't need this negative 1.25. So first of all, we break this up. This is e to the negative 3.75 times e to the negative 1.25. And the next step, I'm going to pull this e power negative 1.25 out because that's not belonging to the Poisson PMF. I need this e to the negative 3.75 over k factorial times 3.75 per k. And now that exactly is Poisson PMF with mean 3.75. And we are summing all the values of it. Remember, Poisson values go from 0, 1, 2, up to infinity. And we know that sum of all the values of any PMF, let alone Poisson PMF, is 1. So we already had this e to the negative 1.25 outside. And this comes out to be 0.287. That is choice E.